Hello, I'm Jeff Miller from Queen Mary University of London, and I'd like to tell you about Polar Manhattan Displacement. PMD is a way of mathematically describing the differences between the tonal properties of groups of notes. Although PMD can be applied to any pitch class set, for the sake of clarity, this presentation focuses specifically on chords. Chords can be represented as tonal interval vectors, or TIVs. A TIV is created by taking the discrete Fourier transform of a chord's chromogram and focusing on components F1 through F6. The magnitude and phase of each component describe the strength and orientation of a particular musical interval type, giving insight into the way that chord sounds. For our study, we used binary chromograms. We present Polar Manhattan Displacement, a multi-dimensional extension of the L1 Manhattan distance applied to pairs of magnitude and phase values. PMD measures the pairwise distances between the Fourier components of two TIVs, thus describing the differences between the chords in terms of their musical interval content. PMD is directional, so encodes the order of chord transitions, and multidimensional, so describes each intervallic difference separately. Significantly, the overall PMD between two chords remains consistent regardless of which chords or how many other chords have occurred in between them in a sequence. This allows us to numerically compare different versions of similar chord sequences. We can visualize these properties using a simple graph. The horizontal axis represents the movement from one chord type to another, and the vertical axis represents transposition. Each point represents a chord's TIV, and each arrow represents the displacement between two TIVs. The fat arrow represents the PMD from a G7 chord directly to a C major. Notice that it is directional, like the chord transition itself. The smaller arrows represent two chord sequences that travel from G7 to C major. If we sum the PMDs of either sequence, they will equal the original direct displacement. In other words, we can inspect each chord transition while the overall displacement remains the same, regardless of variations in the sequences. Musicians often substitute chords for one another to provide harmonic variety. For example, it is common practice to replace a dominant seventh chord with another whose root lies an augmented fourth away. This is known as a tritone substitution. PMD can provide an objective means of numerically describing and inspecting the tonal properties of such relationships. Furthermore, all tritone substitution pairs have the same displacement value, allowing us to identify the relationship. Many MIR tasks could benefit from the ability to autonomously identify certain chord progressions, particularly those which are harmonically significant, such as the 5-7-1 progression. In most cases, a particular chord progression can be identified by its unique PMD value, regardless of transposition and without the need for any chord annotation. For example, any 5-7-1 progression will have the same PMD regardless of the key involved. We believe that Polar Manhattan Displacement could make it possible to programmatically investigate large corpora of chord sequences to analyze the distribution of common chords and harmonies. This could have applications in the fields of computational musicology and content-aware music recommendation, as well as providing an objective measurement of musical similarity for the investigation of authorship and to some extent plagiarism. There are many more details in the paper and more examples on the poster. Please get in touch if you want to discuss it further or come visit our poster. Thank you very much for listening.